Okay, give me DPP. DPP. So one question is there. You see one question. #21. Question 21. See, it is given in NCERT also. Everyone have this? Question 21. So pulley system is there. So case 1. What is case 1? Ceiling is there. This is the ceiling. Clamp, pulley. String is passing over pulley. What is the block on left side? M. Block on right side? 2M. Now find acceleration in this case. What is the acceleration? Difference by sum into G. So what is the answer? G by 3, correct. G by 3 means 0.33 G. 1 by 3 is 0.33. 1 by 3 is 0.33, correct. Now what is case 2? What is case 2? Ceiling is there, clamp is there, pulley is there. Left side, what is the block? M. Right side, what is the block? M. And now you are pulling this M with a force, and that value of this force is mg. Okay, see, one block here, one block here. You are holding this block and pulling it down. What force you are exerting? Mg. Okay, so what is the free body diagram of this M? For this M, what tension is upward? Okay, tension is upward and downward is mg, weight, and this force is also there. You are holding it and pulling it. Suppose I am holding it and pulling it down. So what force I am exerting? Mg. Okay, clear? Now free body diagram of this: upward tension, downward mg. So now solve this. So what is the downward force? 2 mg. Upward force T. So you will write 2 mg minus T is equal to ma. Very good. For this, what you write? T minus mg. Very good. Is equal to ma. Okay. Now you solve this. How will you solve? Add. If you add, what you get? T minus T cancel. Mg is equal to 2 ma. Mm cancel. So what is the acceleration? G by 2 means 1 by 2 means 0.5. So what is the acceleration in case 2? What is the acceleration? 0.5 G. What is acceleration in case 1? 0.3 G. Okay, 0.33 G. Which is greater? 0.5 G greater. Are you getting? Huh? So this is conceptual question. Okay. To check FBD. Okay. So acceleration is less in case 1, more in case 2. So second option, right? So note down. Second option. Which question? Same question. Hmm. the acceleration of mass m in each case. In case A, so in case A, what is the acceleration? 0.33 g. It is less than case 2, correct? So third option, right, correct, good. Third option, acceleration of mass m in case A is less than case B. Okay, case B is 0.5 g, right? Case B is 0.5. Okay, clear? So okay, understand. Note down. So few more conceptual point we'll discuss. Okay, so see, note down. So here external force is not there. I'm not holding any block in this case. They are under gravity only, right? 2m is falling down, m is going up. Okay, only gravity. I'm not holding anyone. No touch here. But here, this m. Okay, suppose external force is not there. Then what is the acceleration? 0. Very good. Acceleration is 0. But I am holding it now and pulling it down with force mg. So this is the FBD, free body diagram. Okay, so now there is a fifth question. So see fifth question. Okay, clear? See fifth question. You can note down which string break. Which string break first? Which string break first? Why string break? First of all, tell me. Why string will break? Because of tension, right? Suppose there is a ceiling. This is the ceiling, and there is a string. I'm holding this string, and I'm pulling it down. So the atoms and molecules, they are holding each other, but I am pulling it down. So when my force is very much, I am exerting very large force. So atoms and molecules cannot hold, correct? Cannot hold. So a string will break, correct or not? Same thing, suppose I am holding paper here and you are also holding here. Now you are pulling this end here, I am pulling this end here. What will happen? It will break, correct? Why? Because you are exerting force. You are exerting force here. So I am exerting force down. Okay, I am exerting force here. So it will break. It break. Which point it is weak? It will break here. Suppose this point is weak here, it will break. Okay, clear? So why string breaks? Why? Because of tension. String break because of tension. Okay, if more tension means more chance it will break. So maximum tension it can sustain. Maximum tension it can sustain is also known as breakdown strength. Okay, breakdown strength. Maximum tension it can, suppose maximum tension it can sustain 100 Newton. Suppose 100 Newton is maximum. So 10 Newton, if you apply 10 Newton, it will break. Maximum is 100 Newton. 10 Newton you apply, it will break? No. 90 Newton also you apply, it will break? No. 99 Newton, it will not break. 100 Newton also, no break. But more than 100 Newton, 101, 110, it will break. Correct? It will break. Clear? So every string has some limit. Which has more limit? Thin string or rope? Which has more limit? Rope or string? Which has more breakdown strength? Rope has more break down strength. Okay, heavy mass you can attach, more force it can sustain. Okay, more force it can sustain. Rope, string has less strength. So now you see, suppose two strings are there. This is one string, and this is the block M and another string. So now you are exerting force F here. You are holding this string. You call it string 2, and this is string 1. String 2 you are holding and pulling it down. So what is tension in this string 2? What is tension in string 2? Tell me. You are exerting what force? F. So what is tension in string 2? F. You are pulling it down. F. So tension in this F. And what is tension in this string 1? Here what is the force? T2. Here what is the force? T1. So T1 upward, T2 downward, and mg also there. So what is T1? T1, T2 plus mg. Okay. So what is the value of T1? T2 plus mg. So which is more? T1 or T2? Which is greater? T1 is greater. Correct? T1 is greater. So when you are holding it and pulling it down, which string will break first? String 1 or 2? String 1 will break first. Okay. So when you are holding it and slowly you are trying to pull. Okay. So that is on a slow jerk. Slow jerk. Slowly you are pulling it down. Slow jerk. So which will break? String 1 will break. String 1 break. Okay. So when you are slowly pulling it. Okay. Clear? Slowly pulling like this. Slowly I am holding it. Slowly I am pulling it. Okay. That is known as slow jerk. Sudden jerk like this. This is sudden. Like this. Sudden. This is sudden. Okay. This is slow. Are you getting or not? So suddenly if you exert jerk sudden, which string will break suddenly? Now you are exerting force sudden jerk. So which string will break? Which string break? Tell me. Sudden. 2 will break. Okay. Are you getting sudden? So what is the answer? Sudden jerk is given to C. So which will break? AB or BC? This point is A, this point is B, this point is C. AB string will break or BC string will break? BC will break, sudden jerk. Okay. If you exert sudden jerk, this will break. Slow jerk means which will break? This will break. Hmm? See, suddenly, when you pull it suddenly, there is no time to pass the force to this. Okay, to this string, because suddenly you are exerting force, so it will break. When it will break, suppose it breaks, so now you are not doing anything to this block, string breaks, correct or not? But when you exert slow force, so it is connected, it is not breaking, it is connected. Okay, so tension is passed here. So suppose you are exerting 10 Newton here, and this is also 10 kg, suppose this is 10 kg, and you are exerting 10 Newton here. So what is the tension here? 10 plus 10 plus 100. 10 plus 100 how much? 110. 110 Newton. Suppose you are exerting 10 Newton here. So what is the tension here? 110. So this will break first. Correct? This will break first. Because tension is passed. Tension is passed. Here there is no time to pass tension because string break. Suddenly you are pulling, so string will break. No time to pass tension. Okay? Are you getting? Okay, fine. Then free body diagram. So this is question 9, question 9, question 10, okay, question 11, 12. So correct free body diagram, correct free body diagram, correct free body diagram. See, in correct free body diagram, draw real forces, draw real forces, no components, no components, don't draw components, okay. Suppose this is the inclined plane, this is the block. So what are the real forces? What are the real forces? Normal and mg, only these two, okay, only these two, correct. How many forces? How many forces? Two forces, okay. This is question number 10, only two forces. So this is correct diagram. If you take component, so when you are taking component of mg, then don't draw mg again. See, if you are considering components, so you can draw like this. So what is this component? Mg sin theta, this is mg cos theta. Again don't draw mg, no, okay. So when components are there, don't draw again mg, no. Draw mg like this or components, okay. So this is also correct, this is also correct, this is correct, this is correct, and this is wrong. This is an mg, mg cos theta, mg sin theta. This is correct or wrong? This is wrong. Okay, this is wrong. Draw components or only force, real force. So fourth option correct. So okay, clear. The ninth question is there. Suppose this is the block. Ninth question. You are exerting force like this. How many forces? Normal, mg, and this force. This direction of this force is like along this line. Okay, so this is the force. So this is the correct free body diagram. Okay. So second option. Then one spring is there. 12th question. Free body diagram of B. So suppose this is the inclined plane. So this is the inclined plane. Now this block is B. Spring. This block is A. And this is F. And this angle is theta. So you have to assume it is smooth. Okay, they should mention here it is smooth. So you are pulling A up like this. So spring is elongated. So spring force on A, up or down? Spring is elongated, so spring is elongated, so it will pull A down. So Fs here and F here, correct? And normal mg, correct? For B, Fs will be up. So this is Fs and mg normal, Okay, clear? So this is the diagram. This is the FBD for B. Okay, note down. This is the FBD for B. So it is given in fourth option. Okay. Spring is elongated. Spring is elongated means it will pull B here and pull A down. Are you getting or not? Like this. Suppose if I ask question, you answer this. See, suppose this is A, this is B. Now this is the spring. Now you are exerting force on A. You are exerting force on A. Now you tell, spring is elongated or compressed? Compressed. Spring will be compressed. So what is the direction of Fs? Downward. So for A, Fs will be down the plane. This F will be up, and normal N1 mg downward. For B, what is the direction of Fs? Up. Okay, like this. So for B, Fs will be up the plane, up the plane. Fs direction is up the plane, mg downward, and this is normal. Okay, N2. Spring compress. When spring is compressed, spring force will push B. Here spring is elongated, so it is pulling A. Okay, it will pull this A here. Okay, clear, understood? Compression means spring will push. Elongation means spring pull. Any other question? Tell me, any question? Which one? 17. 17. Block mass system, determine normal force on A due to wall. So this is the wall, this is the floor, now this is block A, this is block C, this is block B. So you have to find normal force on A due to wall. Normal force on A due to wall. Normal force on A due to wall. Okay. See, is there any force acting on B like this from here? No. So B is not going right side because I am not pushing B like this. Is there any force like this? No. Is there any force like this? Oh, it is there. Yes, correct. Good. It is there. 25 Newton. How much force? 25. But B will go right side or not? No. Who will stop? A will stop. So A will exert force on B. Where? Left. So for B, 25 is right side and normal from A, left side. Okay. So this is normal on B due to A. Okay. So what is this value? 25. So normal on B due to A is equal to 25. Now if you draw free body diagram of A, so, and yes, one more force is there for B, normal upward. Ground will exert normal, floor will exert one normal, you can call N1. Mg is there, so mass of B is 3, so 30 Newton, correct? 3g, okay, clear? So N1 will be 3G, NBA will be 25. Now for A exert normal on B, how much? 25. So B will exert normal on A, right side, 25. So this is normal on A due to B. So that is equal to 25. Wall will exert normal on A. Why? Because A is going right side or not? B is pushing A right side. But A is moving or not? Not. Who is stopping it? Wall. So wall is exerting force on A. Left. So this is normal on A due to wall. So what is the value? 25. Both are equal. And C will exert normal on A downward. So normal on A due to C. And ground will exert one normal. You can call it N2. And mg of A 50. 5G. 5G. So 50. Clear? Now you draw free body diagram of C. So for C, it is 1 kg. So downward is 1G. Now you check the diagram. C and wall, they are in contact? No. C is in contact with A. So A will exert one normal on C upward. So this is normal on C due to A. Only two forces. So balance it. So what is the normal on C due to A? 1G. 1G means 10. Correct? So what is normal on A due to C? 10. Action reaction. We call it action reaction. If this is action, so this is reaction. Correct? Action reaction. C is pushing A down. So A is pushing C up. Action reaction. So what is N2 now? You tell. What is N2? 60. Correct. So N2 is equal to 10 plus 50. 60. N2 is equal to 60. So the force exerted by floor on A is N2. So floor exert on A. Floor exert normal force on A. So what is the value? 60. And wall exert on 5 kg. That is A. How much wall is exerting? 25. Okay, third option. Understood? Okay, this is the option. 25 and 60. Okay, tell me any other question? 15. Elevator I will teach. Elevator I will teach. Any other? Done? Which one? 27. 27. Block of mass 4 kg suspended through two light spring. Balance A and B in parallel. So this also I will teach. So, but it is not that difficult. See, parallel springs are like this. They are identical. They are identical springs. Okay. Identical spring means spring constant same. So what is the tension here? Mg. So what is tension here? Mg. So how much tension here? Mg by 2. How much tension here? Mg by 2. Because identical. So Mg by 2 plus Mg by 2 is equal to Mg. So what is the reading here? Reading. What is the spring force in this spring? Spring force. Spring force is equal to Mg by 2. So what is the reading? Reading, what is the formula for reading? Spring force divided by G. So how much is reading? M by 2. Reading is M by 2. So what is the M? M is 4. So what is the reading? 2. So both will read 2. Okay, I will teach the, don't worry, I will teach this. So more detail I will teach. Any other question? Tell me any. Finish. Take this hose. Okay, next. Which one? Weakest force. Yes, good question. So fundamental forces are there. How many fundamental forces? Four. Four fundamental forces. Which is the weakest? Tell me. Gravitational force. Very good. Gravitational force. Which is the strongest? Strong nuclear force. Strongest is strong nuclear force. Strong nuclear force, strongest. After that, electromagnetic. Electromagnetic. After that, weak nuclear force. Weak nuclear. After weak nuclear force, gravitational force. Okay. So remember this sequence: strong nuclear force, electromagnetic force, weak nuclear force, gravitational force. Okay, clear? Okay, remember this. So let's continue. Let's discuss more on string and spring, right? So write down. So we'll do one topic now, a new topic you write down. Based on a spring only, you can note down topic spring cut. Spring cut and string cut. Spring cut and string cut. Spring cut and string cut. Okay. So yesterday we discussed. Let me revise little bit. So suppose this is the ceiling and one spring is there. The spring constant is K. Block is M. Mass is M. Okay, tell me, what is the spring force upward? How much spring force? Tell me. Mg. Suppose one spring is there, block is M. Another spring is there, another block 2M. So now this is spring 1, this is spring 2. So for this block, what is the upward force? Spring force 1, downward force mg, and spring force 2, downward, correct? Both springs are elongated, and for this 2m, fs2, spring force 2, upward, 2 mg, downward. So what is fs2 value? 2 mg, very good. What is fs1 value? mg plus 2 mg. mg plus fs2. So mg plus 2 mg. So what is fs1? 3 mg, correct? So how to find fs? How to find fs? Okay, how to find fs when block at rest? Block at rest. Okay, how to find fs when block at rest? Block at rest means forces are balanced. Okay, forces are balanced. Forces are balanced. Upward is equal to downward. Clear? Upward, downward equal. How to find fs? So here mg downward, fs upward, so equal. So here fs is mg. Here fs upward, mg downward. So fs is equal to mg. Okay, 2 mg, 2m. fs2 is 2 mg. Clear? Now here two springs are connected for this block. Both are elongated. First spring will pull it up. Second spring will pull it down. Mg is down. So fs1 is equal to mg plus fs2. Clear? Understood? Okay, fine. Now let's come to topic string cut, spring cut. Okay, let's see. So see, suppose this is the ceiling and one spring is there. This is the spring. This is the block M. Now there is a string. Now the block is 2M. So in this diagram we have spring and string. Okay. Now I can cut spring here. I can cut spring here. And I can cut string anywhere. If you cut here, here, anywhere you can cut string. But spring, if you cut here, what happens? If you cut here, what happens? Okay. So 3 points are there. Suppose this point is A, this point is B, this point C. Now you cut it. Okay. So cut like this. This is the scissor. Okay. Now you are cutting it. What happens? Tell me. What happens? So note down. Draw this diagram. If we cut spring at A, what happens? If we cut spring at A, what happens? So think. Spring is elongated. So spring has inertia. Okay. Note down. Spring has inertia. Okay. It does not change its state suddenly. It does not change its state suddenly. Spring is elongated or natural? Tell me. This is spring. Elongated. Correct? Suppose elongation is x. Suppose elongation is x. So right now elongation is x. If you cut spring at A, so ceiling is not connected anymore. Ceiling is not connected. So here force will be absent, but it is elongated. Spring is elongated. So what is the force on this M? Spring is elongated. So what is the force on M? It will look like this. Now this is the block, spring, block, and 2M. Ceiling is not attached. After you cut it here. Now ceiling is not there. Correct or not? Ceiling is not there. No correction. But spring is elongated still. Still elongated. Correct or not? So the force on M. What is the force on M? Upward. Same as before. What is before? How much Fs before? Tell me. Mg plus T, and T is equal to 2mg. So what is Fs? 3mg. Fs is 3mg. Very good. So here also Fs is there. Same value. Here also 3mg. Okay. Fs is 3mg because still elongation is there. Still. And downward force mg T. So, and for this T upward 2mg. Okay. So what is the net force on M? Now, what is the net force? Now what is the net force? 3mg up, 3mg down. What is the net force? 0. So acceleration is 0. So acceleration of M 0. Okay. So you are cutting it here, but spring has inertia. Spring has inertia. What is the meaning of this? Spring has inertia. What is the meaning of this? it does not change its state suddenly. Okay, when you elongate the spring, suddenly it will not come to natural state suddenly. Okay, so immediately after this is cut here. Okay, so what is the acceleration of block immediately after you cut here? 0. Okay, when you cut it here, immediately after that acceleration of this 0. And what is the acceleration of 2m? What is the tension value? 2 mg. So this is balanced. So what is the acceleration of 2m? 0. Okay, so you are cutting the spring here. So spring has inertia, it does not change immediately or suddenly. Okay, so immediately after cut at A, spring still has same elongation. Spring has same elongation. So spring force does not change. Spring force does not change. Okay, spring force does not change. Spring force is fixed. Spring force fixed. So this Fs is 3 mg, because before what is Fs? 3 mg. So now also what is Fs? 3 mg. And downward is also mg plus t. T is 2 mg. So downward 3 mg, upward 3 mg. So force is balanced. So acceleration 0. Okay, clear? So acceleration 0. Now you cut at B. Next page. Now you cut at B. Now this block is M. String is there. This block to M. Now this point is A, B and C. A, this point is A, this point is B, this point is C. Now you cut at B. Okay. You cut here. What happens? So initially, before cut, what is the situation? Fs is acting upward. So before cut, what is the force upward for M? Fs 3 mg. Very good. So Fs is equal to 3 mg. And what is the tension on the string? 2 mg. Very good. Tension is 2 mg. Okay. Now after cut, this is the situation. Now there is no connection. There is no connection between spring and block M. Correct? So spring is detached. Spring is detached. So is there any spring force on M? No, because spring is not connected. So spring force not there. So what is the force downward? Mg. Correct. Tension also there, suppose. So T. And for 2M, what is the force upward? Tension. And downward? 2 mg. Correct. So they will fall. See, what is the direction of net force on M? Downward. Is there any upward force? No. So M will fall. Correct. So M is falling, 2M is also falling. So now calculate acceleration. Acceleration you calculate. So if we imagine the string is straight again, okay, so same acceleration. So what do you write for this? 2 mg minus t is equal to 2 ma. For this, what do you write? Mg plus t is equal to ma. Now you add these. Add, tell me. 3 mg is equal to 3 ma. 3m cancel. So what is the acceleration? G. So free fall. Okay. So acceleration is G. The two blocks are falling with what acceleration? What is the acceleration? G. And what is the tension? Now solve this. Put A equal to G here. So what is the tension? 0. Good. So 2 mg minus T is equal to 2 mg. So tension will be 0. So tension on a string becomes 0 and the block M and 2M are falling freely. Freely falling. This is known as free fall. What is free fall? Free fall means what is acceleration? G. Okay. This is known as free fall. This is free fall. When acceleration is G, that is known as free fall. Note down. So acceleration is G, free fall. Okay, clear? So when you cut at B, block M and spring, no connection, detach. So no spring force. We assume, suppose tension is there, mg is there, okay? For 2m tension upward, 2mg downward. And if tension is there, so acceleration will be same. Acceleration same means acceleration of this A, this also A. So mg plus T is equal to ma. There what 2mg minus T is equal to 2m. Okay. Solve this. Acceleration is G, tension is 0. Note down. Tension is 0 means no tension in string, no tension. Free fall. Okay, it is free fall. Done. Now last. What if you cut at C? Not cutting at A, not cutting at B, cutting at C. What happens? So that is the third point. Okay. So, okay, clear? Next page. C. So what if you cut at C? So M string now 2M. Okay. So 3 points are there. A, B, C. Now you are cutting here. Okay. Okay, cut here. Cut here. So what happens? Tell me. Cut here. Cut. Tell me. String is cut. Immediately after that, tension will be 0. So for 2M, what is the force? Is there any tension upward? You are cutting this string. Any tension? No, no tension. So what is the force? 2 mg. Very good. 2 mg. And for M, is there any tension downward? The string is cut. So no tension. So downward, what is the force? Mg. And upward, what is the force? Fs. And Fs is same as before. Fs is same as before. Fs is same as before. What is the Fs before? Before cut. Before string cut. What is the Fs before? 3 mg. Fs before is 3 mg. So what is the Fs now? 3 mg. Okay. Same as before. Fs will not change. Fs will not change. Okay. The spring is connected to M. So Fs is there. Fs will be same as before. Okay. So tell me. So what is the, which force is greater now? 3 mg is greater. So what is the net force? Correct. So 3 mg minus mg is equal to ma. ma. So 2 mg is equal to ma. So what is the acceleration value? 2g. And what is the direction of acceleration? Direction of acceleration? Upward, correct? Direction of acceleration is upward. It is gone, huh? Oh my God. to search full. Okay, no problem. I will draw again. So this is the spring, and this is the block M string. This is block 2M. Okay. Now 3 points are there. A, B, C. You are cutting at C. Okay. You are cutting at C. So what is the spring force before? What is the spring force before? 3 mg. Very good. Now after cut at C. So for this block, what is the upward force? Fs. 3 mg downward force mg. So acceleration will be upward. So 3 mg minus mg is equal to ma. So what is the value of a? 2g. Direction upward. Very good. So immediately after you cut string, you cut string at C. Acceleration of B is 2g upward. Sorry, acceleration of M is 2g upward. Now for 2m you tell 2m after cut. What is the downward force? 2 mg. Any tension? No, no tension. So 2 mg is equal to 2 ma. So 2m cancel. So what is the acceleration? G. And what is the direction of acceleration? Downward. Downward. Okay, note down. So when string is cut, acceleration of 2m is g downward. Acceleration of m is 2g upward. Okay, clear? So note down. Okay, so this type of question, you will have spring, string. You may cut here, you may cut here, you may cut here. Okay, 3 cases. Okay. If you cut here, acceleration will be 0. If you cut here, free fall, both will fall freely. Okay, clear? Okay, now you solve the same question. You write 2m here and m here. Interchange. Now solve. What happens if you cut at A? What happens if you cut at B? What happens if you cut at C? Okay. So note down. Solve the repeat this question. Interchange the blocks. 2m here, m here. See, this is the question now. Spring, what is the mass here? 2m. What is the mass here? M. Okay. So 3 points are there. A, B, C. If cut at point A, what happens? Tell me. If you cut at A, what happens? What is the acceleration of 2m and m? 0. So both blocks 0. Okay. A1 is equal to A2 is equal to 0. Suppose this is block 1, block 2. If cut at B, tell me what happens? Free fall. Both blocks fall freely. Means what is the acceleration? What is the acceleration? G. Direction? Downward. So both will fall freely. Okay. Free fall. This is free fall. So acceleration is minus G. Acceleration is minus G, downward. Okay, clear? If you cut at A, nothing will happen. What is the acceleration? 0. If you cut at A, acceleration 0. Both. If you cut at B, spring detach, both block fall freely. Now what if you cut at C? Tell me. Before cut at C, for 2m, tell me, what is the upward force for 2m? Fs, downward force, tension, and 2 mg. And for m, what is the upward force on m? Tension, downward force, mg. So how much is tension? Mg. How much is spring force? Tension plus 2 mg. So 3 mg. Good. Okay, so Fs is 3 mg. Now after cut at C. Now you are cutting at C. So string is cut. So what is the new value of tension? C is cut. So what is the tension force? 0. No tension. So 2m. What is the upward force on 2m? Fs, downward force, 2 mg. Any tension? No tension. String cut. And for m, tell me, for m, tell me. Downward force, mg. Any tension? No tension. So now find acceleration of this. What is the downward force? Mg. So mg is equal to ma2, cancel. So what is acceleration? G. And direction of acceleration? Downward. G. So free fall. So second block will fall freely. Okay, this is free fall. So when you cut it here, this will free fall. Now 2m, come to 2m. What is the upward force? 3 mg. Downward force? 2 mg. So what is the resultant? 3 mg minus 2 mg is equal to 2m A1, correct? Mass is 2m. So what is the answer? 3 mg minus 2 mg? Mg is equal to 2 ma. Cancel. So what is A1? G by 2. Direction? Up or down? Up. Upward. Correct. Good. So note down. Acceleration of block 1 is G by 2 up. Acceleration of block 2, G down. Okay, so concept is spring force will not change. What is the spring force before? Same spring force after. Okay, the spring force will not change. So that is the concept. Fs will not change. Fs same. Okay, Fs not change. Before Fs 3 mg. Now also Fs 3 mg. Okay, but what is missing here? Which force is missing here? Tension is missing. Okay, no tension because string cut. Okay, string cut. Okay, clear? Are you getting or not? Easy, understand this. Okay, so now I will give one more question next. I will ask now so many type question. I can put a string here, here spring, or here 3m, here 2m. Okay, or spring here, I can change the values of masses. Okay, so practice this question. One time it came, you see 2020, I think one question was there, 2020 or 19, one question was there like this. Okay, clear? So again it can come, chances there. Okay, so next it can come, string cut and spring cut. So note down. So now I will give the question, next question I will change the values. So you answer. Okay, so note down. Spring is here, this block 2m, and string is here, this block 3m. Okay, Find accelerations of block 1 and 2. This is block 1, block 2. Find accelerations of block 1 and 2 blocks. Find accelerations of block 1 and 2 immediately after string. What is this string? This is spring. String. After string is cut. Okay, solve. String is cut. So what is the Fs spring force? First you find spring force. What is the spring force before? Okay, solve. Try. First you tell what is the spring force. 5 mg. 5 mg. Good. Solve. Do it. Final answer I want. Tell me what is A1, what is A2. Final answer with direction up, down. Okay. A1. A1 is equal to 3g by 2. Up or down? Up or down? That direction also you have to tell. Upward. 3g by 2 upward. Okay. So for block 1, Fs upward, 2 mg downward, tension downward. This is before cut. For 2m, for 3m, tension upward, 3 mg downward. So tension value 3 mg. Tension is 3 mg. So Fs will be 5 mg. Fs is 5 mg. Now after string cut, so 2m, so Fs there, 2 mg there, but tension not there. Tension missing, not there, tension not there. So for 3m, tension not there. So only this 3 mg. For 2m, Fs and 2 mg. Tension not there. So for 3m, what you write? For 3m, what is the net unbalanced force? So 3 mg is equal to 3 ma. 3m cancel. So what is A2? G, direction downward. Okay, for this what you write? Fs value same as before. Tell me. So what is net unbalanced force? 3 mg. Very good. So 5 mg minus 2 mg is equal to 2 ma. 2 ma1. So 3 mg is equal to 2 ma1. Okay, so mm cancel. So a1 is 3g by 2. Okay, note down. Direction upward. Clear? So done. Okay, next question. String here, spring here. can solve. Next question, you draw string spring. So I will and change the masses also. M M here 3M. Okay. So next question you write down string M spring here 3M. Okay, now you solve. Here you cut the string. So question is find accelerations of block 1 and block 2, block 1 and block 2 immediately after string is cut. String is cut. You are cutting here, cut here. So find A1 and A2 direction. Okay, up or down, up or down. G by 2 up, G by 2 down, 3G by 2 up, 3G by 2 down, G up, G down, like that, up, down. Okay, how much acceleration with direction? Okay, try. So think like this. Before, what is the situation? Before cut, you can tell what is the tension before cut. 4 mg. Good. So for block 1, tension upward, mg downward, fs downward. For block 2, fs upward, 3 mg downward. So where fs value is 3 mg, fs is 3 mg, fs is 3 mg. So T will be 4 mg. T will be mg plus fs. Fs is 3 mg. So tension is 4 mg. Okay. Now string cut. Now string cut. Now string is cut. Now this is 3m. M and 3m. Any upward force on M? No. Tension is gone, missing, no tension. Tension is missing. Downward force. Mg. Fs also there. Fs is also there. For 3m, Fs upward, 3 mg downward. Fs does not change. Fs same as before. Fs same as before. Fs no change. What is Fs before? 3 mg. So what is Fs now? 3 mg. So Fs now also 3 mg. So what is the net force? 0. So for this block, for 3m, net force 0. So what is acceleration? 0. Acceleration 0. For this, what is the net downward force? Mg plus 3 mg. So mg plus 3 mg. Mg plus 3 mg. So what is the net force? 4 mg. Now 4 mg net force is equal to mass into acceleration. Mass is m, acceleration a1. So what is the acceleration? 4g. Acceleration is 4G. Direction downward. So A1 is 4G down, A2 is 0. Okay. So answer is like this. A1 is 4G down, A2 is 0. Okay, this is the answer. A1 is 4G down, A2 is 0. Now you solve the same question, interchange the masses. Take 3m here, m here, and solve. So previous question, spring here, string here, spring here, string here, string, spring, right? String, spring, m, 3m. Now next question, 3m, m. Okay, last. Same question, find acceleration of blocks 1 and 2 immediately after string is cut. Okay, take 3m here, m here. Okay, solve. String, 3m, spring, m. Okay, now solve this. This is block 1. This is block 1, block 2. Okay. Okay, last question. So before cut, tell me how much is spring force? Okay, you calculate. Think like this. Before cut, like here, what is the before cut? Before cut, what is the tension? Okay, clear? 4 mg, Fs 3 mg, correct? After cut, no tension, mg, 4 mg, mg plus 3 mg is 4 mg, so 4 mg is equal to ma. A is 4g down. For this, 3 mg up, 3 mg down. What is the net force? 0. So acceleration 0. Okay, understood? Okay, solve this. Okay, before cut, before a string cut, tension upward. Okay, solve. Do it. Huh? Tell me. A1, any answer? 4G? Up or down? By 3. Okay. Up or down? Downward. A2? 0. Okay. So before a string cut, tension upward, 3 mg down, Fs down. For m, Fs up, mg down. So Fs value is mg and tension value is 4 mg. Okay. Now after string cut, so string is gone. So 3m here, m here, no tension, only 3 mg downward, Fs downward. For m, Fs upward, mg downward. So Fs is mg. So 4 mg is equal to 3 ma. Many students do mistake here. They will write like this. 4 mg is equal to ma. Okay, this is wrong. What is the mass of this block? 3m. So 3 ma. Mm cancel. So A1 is equal to 4g by 3. Good. Net force is downward. So this acceleration is downward. And for this block, Fs is mg. Downward force mg, upward force also mg. So net force 0. So acceleration is 0. Okay. Correct. Good. Okay. So one question is there. Give book. So that MTG is there. MTG past year also. Okay. So errorless also you carry it. Okay. So errorless also important. Who has a errorless? Errorless anyone? Ah, okay, okay. MTG. Hmm? That blue color book is there. PYQ. We revise it. Okay. It is easy. Concept is easy. Just revise. Okay, where is the question? It is not there. Yeah, one question is there. Yeah, 2017 it was there. Page 288. Page 288, question 11. Okay, solve this. Homework. Homework it is. MTG. So, same question it is there. PYQ. This is PYQ. So, same it is there. Any more question? No, no other question. No problem. Okay. Okay, we'll continue. That's it. That's it. Okay, only one question is there. Okay.